Real number arithmetic. All right, so we'll start with addition and subtraction. So you can always think of real number addition or subtraction with integers, decimals, or fractions. You can think about it in terms of the number line. So if we think about our number line here and think about addition as moving to the right on the number line, subtraction is moving to the left on the number line, then that can help us out. So for example, if we look at number 45 here, we have -1 minus 5. So that's -1. So we can draw out our number line here. So let's say that's 1, that's 2, -1, -2, -3, -4, -5, -6, -7. All right, -8. So we can start at -1, which would be here on our number line. And since we're subtracting 5, that means we're moving 5 to the left. So 1, 2, 3, 4, 5. So that puts us right here, which is at -6. So the answer here is -6. You can also think about this by using the properties of addition and subtraction, meaning you can change the equation. You can change it from subtraction to addition. So I can rewrite this as -1 plus -5. All right. -1 minus 5 is the same as -1 plus -5. So thinking about it in terms of subtraction, if I have -1 and I add it to -5, -1 plus -5 is -6. All right, here we have number 46. This is 4 plus -1. We can do the same thing. We can transform this to subtraction. 4 plus -1 is the same as 4 minus 1, and so that just gives us 3. Okay, number 47, we have -6 plus 6. Here, the numbers just cancel out. So remember that a negative number simply means the opposite of its positive. So the -6 is literally means the opposite of 6. So the opposite of 6 plus 6 gives me 0. And then here again, we have 5 minus 6. If we want to, we can rewrite this using addition. So I can say this is 5 plus a -6. All right. And either way I think about it, I know I have a -6. My -6 is larger in absolute value. So that means my answer has to be negative. Okay. So if I compare the absolute value of -6 to the absolute value of 5, you can see that the absolute value of -6 is larger. So therefore, I know my answer here has to be negative, and the difference between these two in absolute value is just going to give me 1. So my answer here is -1. I used what we call difference, meaning that if the signs are different, I take the difference between the absolute value of the two numbers, and my answer has the sign of the largest one in absolute value. So 5 minus 6 is -1. With fractions, it's the same thing. So here we have a -1/6 minus a -5/6. So anytime I have minus a negative, that's telling me to do the opposite of the opposite, right? So I essentially convert this into addition. So this becomes -1/6 plus 5/6. Some of the students like to think about these two negative signs, minus a negative, the negatives coming together and creating this plus sign. All right, so this is -1 plus 5/6. So we know with fractions, they need the common denominators, which they already have. So then we just add the numerator. So this becomes -1 plus 5 over 6. -1 plus 5, if I like, I can rewrite that as 5 plus -1 over 6. And then I can rewrite that again as 5 minus 1 over 6, which gives me 4/6, which I can then simplify into 2/3. All right, so my answer here for number 49 is 2/3. Okay, number 50, here's another fraction, but this time we don't have common denominators. So we know we'll need to find common denominators. But again, I notice I have minus a negative, so I'm going to go ahead and rewrite that as addition. So this is -3 1/5 plus 3/7. All right, minus a -3/7 becomes plus 3/7. All right, now my next step, I want to convert this mixed number into an improper fraction. All right, so if I have -3 1/5, that's literally the opposite of 3 plus 1/5. So that's going to be, if I multiply the whole number part by the denominator, 3 times 5 is 15, and I add the numerator, plus 1, that's 16. So this becomes negative 16 fifths. Again, I converted this by multiplying the whole number, which is 3 times 5. That gives me 15. And I add the numerator to give me 16. And then it has to, of course, stay negative. So negative 16 fifths plus 3 sevenths. Then we need a common denominator. So my common denominator here can be 35. So this will be a negative, and let's see, this is 35. Well, how did I get the 16 fifths? How did I get the 5 here to become a 35? I multiply by 7. That's what I did. But then if I multiply the denominator by 7, I also have to multiply the numerator by 7. So I have to do 16 times 7. That's mental math. That's 10 times 7, which is 70, plus 6 times 7, which is 42. 70 plus 42 is 112. So this gives us negative 112 35ths plus 3 sevenths converted to a equivalent fraction with a denominator of 35. How did I do it? I multiplied the 7 by 5, but if I do it to the denominator, I also have to do it to the numerator. So I also have to multiply the 3 by 5 to give me 15. And then I can add the numerator. So this is negative 112 plus 15 over 35, all right? So I can clearly see that negative 112 is larger in absolute value. And so therefore I know my answer when I do this addition is going to be negative. Since the signs are different, I know that I'm ultimately taking the difference between these two numbers. So if you do 112 minus 15, you'll get 97. So the answer here is negative 97 35ths. And if we want to convert this to an improper fraction, we simply divide. I know that 35 will go twice into 97 to give me 70. And then the difference there will be 27. So as a mixed number, this would be negative 2 and 27 35ths. All right, a little kind of running out of space, but we got it in there. Okay, so there's our answer there. Now let's look at the last two, which is addition with decimals. Okay, made a little bit of space for ourselves. All right, so here we go. Adding, subtracting with decimals. So we know that the rule for fractions is fractions to add them or subtract them, we need common denominators. The rule for adding and subtracting decimals is that we need to align the decimal points. But here, since we're dealing with real numbers, we have a negative plus a positive. So it's not going to be as straightforward as if we were adding two positive decimal points. So the first thing we have to do is we have to think a little bit about what our answer would be. And again, here we can use the number line, if we like, to give us an idea of what this answer should be. So if we had our number line here and we have a negative 1.5. So let's say this is negative 2 here. This is negative 1. So we have a negative 1.5. We're starting here. And let's say this would be 0. This is 1. This is 2. This is 3. And let's say that's 4. Okay, so we have a negative 1.5 and we're going to add 2.195. So we're going a little bit more than 2. So that will put us 1, 2 plus a little bit, right? So we would expect that our answer here is going to be somewhere between 0 and 1. All right, it's going to be some decimal point in there. And we'll come back and see if that it holds true. All right, but that's one way to think about it, is the number line. But we still need to figure out what the actual number is. So here we are going to apply our what I call same sum different difference. It's kind of a cheat sheet of how we can do this kind of addition and subtraction with real numbers. So the phrase is same sum different difference. All right, sum here refers to addition, difference here written very sloppily. Difference refers to subtraction. All right, so same, meaning that if the numbers that I am adding are the same, have the same sign, meaning they're both negative numbers or they're both positive numbers, then to find the answer, I'm going to take the sum of the numbers in absolute value. But if the signs of the two numbers that I'm adding are different, meaning one negative and one positive, such as what we have here, a negative and a positive. If the signs are different, then ultimately what I'm going to do is to take the difference, meaning to subtract the two numbers in absolute value. Okay, I'm subtracting the absolute value of the two numbers and giving the answer the sign of the one that's largest. So we already know here, I'm adding a 2.195 to a negative 1.5. 2.195 is larger in absolute value. So we expect our answer to be positive because the positive number is the one that's larger in absolute value. If I take the absolute value of 2.195, that's equal to 2.195. If I take the absolute value of negative 1.5, that is 1.5. So this one is bigger. So therefore our answer will be positive. But since the signs are different, we ultimately end up taking the difference between the numbers, between the absolute values of the numbers. So I'm going to take the difference between 2.195 and 1.5 to give me the actual number that is my answer. We know it's going to be positive, and we reinforce that with our number line. But to get the number, we're going to take the difference. So we're going to subtract. So even though this is a plus, this is an addition problem, we're going to subtract. So let's do it. 2.195 minus 1.5. Again, with addition and subtraction, with decimals, we align the decimal points. So we can add zeros here to fill in the blanks, and then we go to work. So 5 minus 0 is 5, 9 minus 0 is 9, 1 minus 5, so we're going to borrow 1 from the 2. So the 1 here becomes an 11. So then we do 11 minus 5, and that gives us 6. We bring down our decimal point. 1 minus 1 is 0. So the answer here is 0.695, positive 0.695. And you see that that aligns with what we predicted based on our number line. Looking at number 52, we can apply the same logic. Same sum, different difference. Well, we can see here that the signs of these two numbers are different. This is a positive number. This is a negative number. So we're going to use different difference, meaning that we're going to look at the numbers in absolute value. So we'll look at the absolute value of 0.228, which of course is 0.228. And we'll look at the absolute value of negative 6.9, which is 6.9. All right, and we can obviously see that this one is larger in absolute value. So since the negative number is larger in absolute value, we know that our answer is going to be a negative something. All right, it's going to be negative. And to find that something, we're going to use the difference between the two numbers in absolute value. So I have the numbers in absolute value here. I'm going to take the difference between these two numbers. So I'm going to do 6.9 minus 0.228. All right, we can add zeros here to fill in the blanks, and then we go to work. 0 minus 8, we need to borrow up, we need to borrow again. So we're going to borrow 1 from the 9 becomes an 8. This 0 becomes a 10, but then we borrow 1 from it, so it becomes a 9, and this 0 becomes a 10. Okay, now we go. So 10 minus 8 is 2. 9 minus 2 is 7. 8 minus 2 is 6. Bring down our decimal point and bring down our 6. And that is our answer, except for we know that it's negative. So the answer here is negative 6.672. And that is how we do real number arithmetic with addition and subtraction.